we're going to look at how do volumes work if you make a composite picture. You add two shapes together or you subtract them off. So we're going to calculate the volume of a composite three-dimensional shape, and our three-dimensional shapes are prism, cylinder, pyramid, cone, sphere, or hemisphere. And we could be putting any of those together. You could actually put two pyramids together. You could put two cones together. You could put a cone with a cylinder. You can't put a cone with a pyramid because a cone has a circle and a pyramid doesn't. So there are some limitations as to which ones can go together. There aren't very many limitations of which ones can be subtracted, but together they tend to be the same base shape. Now you could get creative, and sometimes you are asked to get creative. So there is an opportunity, given a state test or a ACT or an SAT, where they would put some weirder shapes together. So we have two types of examples. We have a situation where we're going to add the two shapes together, or we're going to subtract them off. We're going to look initially at the volumes through addition. So you can see this one's kind of like an ice cream cone. You've got the ice cream cone full, and then there's a scoop. Unfortunately, I have dropped my ice cream cone, and so it's all over the place. But we can still find out the volume of the ice cream that I am losing. So let's look at the two shapes. First shape is a cone, and I know it's a cone because it comes to a point and there's a circular base. So I have a cone, and a cone is 1/3 pi times radius squared times height. And I'm going to add to it this hemisphere. It's not a sphere because it's not a whole ball. It's just kind of up at the top here. I know it's a dip of ice cream, but remember they've kind of smushed it all down in there in that cone. So a hemisphere is 2/3 times pi times radius cubed. So we're looking at 1/3 times pi times the radius of 5, which we're going to square, times the height. Oh, wait a minute, they didn't give us the height. So we have to come over here and remember that this picture is of a right triangle. So as we're looking straight on, it's a right triangle. And I need to find the height. So I have two ways to do it. One is to recognize it as the Pythagorean triple 5, 12, 13. The other way is, oh, I don't recognize it as the Pythagorean triple, so I can do the Pythagorean theorem. And in the Pythagorean theorem, the 5 is one of my two legs. The height is another one of the legs. And then the 13 is the hypotenuse. 25 plus the height squared equals 169. So the height squared equals 144. So the height is 12. So, oh look, I still get a 12. So the height is now 12. Now let's talk about the semicircle. The semicircle, or excuse me, the hemisphere has a radius of 5, so it's 2/3 times pi times 5 cubed. As previously stated, I'm not the biggest fan of trying to get this all accomplished by doing pi separately. I like to do it all at once. But I know that most of you are not comfortable with that. Plus, I also know that I have fractions. So there's a chance I'm going to get some pretty ugly fractions. So I'm going to go ahead and multiply by the pi now, even though it's not my biggest fan thing to do. So 5 squared times 12 times pi divided by 3. So I have 314. Oh my gosh, I've run out of lead. 0.16 plus 2 divided by 3 times pi times 5 cubed. So 261.80. So I'm going to add these two together. I'm going to get an approximate answer of 575.96 centimeters cubed. Now you do get a slightly different answer if you don't have the pi button. You get 575.67 centimeters cubed. So let's talk about another problem where we're going to add them together. The top of the cylindrical container shown has the shape of a hemisphere. The total volume of the container is. So it's the same question as just calculate the volume. They tell you you have a cylinder and they tell you you have a hemisphere. So the radius of our cylinder is also the radius of our hemisphere. Again, it's sitting on top of the other, so we're going to add those together. So we have a cylinder, and a cylinder is pi times radius squared times height, and sitting on top of it is a hemisphere. So we're going to add on to it 2/3 plus 2/3 times pi times radius cubed. So again, the radius for the cylinder is 3, which we're going to square, and the height of the cylinder is 2. Plus we have 2/3 times pi times the radius, which is 3, cubed. Since I don't have fractions, I am going to go ahead and do this intermittently because I really don't like multiplying by pi early. So 3 squared times 2, so 9 times 2 is 18 pi, plus, there's a 3 here, I'm going to take out one of those. So now I have 3 squared, which is 9, times 2, which is 18 pi. So I actually get 36 pi. And now I'm going to multiply by pi. Because like I said, I really like to only do that once. I don't like doing that more than once. So that is approximately 113.10 inches cubed. If you don't have the pi key, it's 113.04 inches cubed. Now, don't get me wrong, you could definitely have made this line right here decimals instead. So you could have gotten about 56.55 for each of those. I just don't like to do that because you're rounding too early. I don't like to round early. So scenario number 1 is that you are adding, one sitting on top of or next to the other one. The next one is through subtraction. A sphere fits snugly inside of a right cylinder as shown below. Find the volume lying outside the sphere but inside the cylinder to the nearest hundredth of a cubic inch. So it's kind of like a container for tennis balls, except there's only one tennis ball on the inside. So if I have a container of tennis balls and I stick a tennis ball in there, how much water can I actually put in there? Well, I can't put water into the tennis ball. It's going to go around the tennis ball. So that means I'm going to have to consider the volume of this cylinder, which is pi r squared. So if there were nothing in there, I could fill up the entire cylinder. But I need to take out the space that's going to be the tennis ball, the sphere. So 4/3 pi r cubed. Because again, when I fill it up, the water's not going to go into the sphere, it's going to go around it. So they did not give us the radius. They gave us the diameter. So we need to make sure we remember to make it a radius. So pi times 1 squared times. So the entire height of the cylinder is 5. Great example that height does not mean up and down. Height means from base to base. Minus 4/3 times pi times the radius cubed. Okay. So again, I have a fraction, so I'm going to go ahead and make it a decimal now, even though I'm not the biggest fan. So we know 1 squared is 1 times 5 times pi. So we're just going to do 5 times pi. Whoops. 5 times pi. Because 1's not really going to make a difference. So 15.71 minus 4 divided by 3 times pi times 1, which is 4.19. So those are the two numbers that I have, and that's what I'm going to subtract. So my volume in my cylinder around the sphere is about 11.52 inches cubed, and that's the hundredths place, so we're good. Obviously you may not have the pi button, so you're going to get a slightly different answer.